way you should approach this review, I think, is read the question, pause the video, think about what the answer is, take a stab at the answer, then start the video again. Okay, go ahead and do that. Now, on this thing, I thought they were missing the square root. Remember, we square the standard deviations, we add them together, and we take the square root of the whole thing. And that gives us our new standard deviation when we add the two groups. But, because we're talking about a sum. But in the question, if you notice, they say variance. Okay, not standard deviation. That's what kind of threw me off. But I did catch myself, and the answer is D, right there. If we square the standard deviation, that's the variance. So we're just add the two variances, and D is correct. Okay, now just remember that for the test. Okay, read this question, see if you can get it. I got a bit of a cold, so you'll have to excuse me, my voice. Okay, now let's see. This is a z-score. This is just a continuous random variable that is a big bear. So 325 pounds. All right, here we go. What are we going to do with this thing? Z-score, 325 minus, what's the standard deviation? No, the mean is 250. The average bear weighs 250. Wow, so that's a big bear. Divided by the standard deviation, which is about 50 pounds. And that's going to be our z-score. And if you do that, it's 1.5. 1.5. So again, I always think about this graph, right? Here's at 0, right? There's only 3 standard deviations, so we're way up here, 1.5 standard deviations up here, 1.5. Anyway, so we're thinking about a bear that is, remember, it's bigger than 325 pounds, so it's way up there, okay? All right, so if you do normal CDF, plug it into the calculator, what do you get? 0.9332. Ooh, look at that. That's our answer. Wait a minute. That is all this stuff is down here underneath. Remember, CDF tells us that. So we subtract it from 1 to get that stuff. Tricky, tricky. So if we take 1 minus 0.932, we should get A. A is actually our answer on this one. Right there. Okay? Oh, and by the way, if you go through these videos and you have any additional questions, feel free to text me on Remind 101, and I'll try to answer those. Okay, let's do the next one. Okay, go ahead and read this one and see if you can figure out what the right answer is. I'll give you a chance to do that right now. Now, this stuff doesn't have a lot to do with this problem, but I wanted to review it anyway. So if you have a binomial random variable, you have that 10% rule, and that is, can we even do this thing? Okay, is the situation or the setting okay to continue with the binomial random variable? So 10% rule. Remember, your sample size has to be 10% or less than your population size. So in other words, if you're pulling out a sample and not replacing it, it's okay as long as that sample size is 10% or less than your population. Now, the other thing is, can you check for whether it's going to be a normal approximation? Remember our normal curve. Whoops, we do all this stuff. Our normal curve stuff, normal CDF. Can we do it with this binomial random variable? Well, yes, as long as these conditions are met. As long as your sample size times the probability is bigger than 10, and the sample size times 1 minus your probability is also bigger than 10, then you can do a normal approximation. In other words, when you do a bigger problem like that, you have to establish these things first before you can continue the problem. Okay, now don't forget about your bins, right? Is it binomial? Yes or no? Is it independent? Do you have a set number of trials, and is each probability the same throughout the problem? Now, this also has to do with geometric probability. Same exact things, except The only difference is here, the number of trials is how long does it take until you get one success. That's the difference between binomial and geometric. Okay, now if you read this problem, right away it kind of jumps out at me that it's going to be geometric, except there's a problem. It's not independent. You still have to test for independent for a geometric probability, and they're not, because they don't put them back in the pile. They just keep flipping the cards over. So our answer in this case is E, none of the above. Okay, let's do the next problem. Okay, go ahead and read this problem, stop the video, see if you can figure it out, and then start the video and see if you're right. Okay. Okay, so here we go. Here are our two formulas for the mean and the standard deviation. So you take the number, let's see, 18 times 0.9, and you should get 16.2. So we're down to these three choices right there. And then if we put this in here for the standard deviation, you should get 1.273. Okay, pretty straightforward if you remember these formulas. And they're not asking you anything about normal approximation or anything like that, because this situation actually doesn't work for that. They're just asking about these answers right here. Okay, so the answer is D. Hope you got it right. Let's do the next question. Okay, go ahead and read this thing, give it a shot, pause the video, I'll be right back. Okay, so this question is all about, do you know bins for a geometric distribution? Okay, choice 1 doesn't make sense. Okay, choice 2, that's only for a binomial random variable. Okay, and then let's see, trials are independent? Yes, we need that for a geometric. And the probability of success has to be the same for each trial? Yes, that also has to be true. And number 5, nope, that doesn't make sense. Okay, so the answer is 3 and 4, which is choice A. There it is. Okay, so far, I'm not sure, but I think that this test is going to be better than our previous test. Okay, let's go on to the, well, I'll make another video for the free response questions. Okay. Whoops, I almost forgot. See you later, bye.